Next we can discuss the types of transformers. There are mainly two types of transformers. One is step-up transformer. Step up means this transformer increases the voltage or amplifies the voltage. That means if we give a 10 volt at the input end, it will comes in an amplified form. That means as 20 volt at the output end of a step-up transformer. The output is always higher than the input which is being supplied. So this condition, that means the output voltage should be greater than input voltage. That means output is secondary, so Vs is the output voltage and Vp is the input voltage. So if this condition Vs greater than Vp is to be satisfied, it is possible only when Ns is greater than Np. Ns means number of turns in the secondary coil and Np means number of turns in the primary coil. So if number of turns associated with the secondary coil is greater than number of turns associated with the primary coil, then the output voltage, that means the voltage across secondary, will be greater. So the voltage across secondary is greater if the number of turns associated with the secondary coil is more. And this is clear from this equation. Vs is equal to Ns by Np into Vp. So if Vs is to be greater, then Ns must be greater than Np. Okay. And similarly, what about the current? We know that power at both the end, that means power at the input end and power at the output end, must be same. Okay. So power at the input end is Vp into Ip, Vi. And power at the output end is Vs into Is. So from this, what is Vs? Vs is equal to Ip by Is into Vp, right? So if Vs is to be greater, then Ip should be greater. That means current flowing through the primary must be more. So here it is greater. Okay children, it is not less than, it is greater than. So the current flowing through primary must be greater than secondary. So the output of the transformer, voltage will be high and current will be less. Okay. So at the output of the step-up transformer, voltage will be high. That means Vs will be high and current will be less. So the current flowing through the secondary will be less. High voltage and low current. That is the output of a step-up transformer. And these are used in power stations which supply power to the houses. Okay. So what will be the structure of a step-up transformer? See, in the primary the number of turns must be less. So number of turns is less in the primary. And in the secondary, number of turns must be greater. See, the number of turns in the secondary coil is greater and we receive the voltage across the output voltage across the secondary, and at the output end we will get high voltage and low current. This is very important. You must remember this. This is the nature of the output of a step-up transformer. High voltage and low current. Okay. And where do we use this step-up transformer? In the power stations which supply power to the houses. Now the second type of transformer is step-down transformer. Step-down means it decreases the voltage. So the output voltage Vs will be less than the input voltage. And this condition is satisfied only if the number of turns associated with the output, that means secondary, is less than number of turns associated with the primary. So if you consider this as your transformer, this is the primary end and this is the secondary end. So the number of turns associated with the primary will be more. So here the primary coil has more turns, but at the same time the number of turns associated with the secondary will be less. Okay. So this will be the structure or a construction of a step-down transformer. And at the output of the step-down transformer, we will get low voltage because it decreases the voltage. So low voltage and at the same time current will be high. high current. Okay, so the current flowing through the secondary will be greater. Is is greater than Ip. At the same time, power will be same. So output is low voltage and high current, and this transformer is used in welding. Now, what are the applications of transformers? The main applications of transformer is the transmission of power over long distances. Suppose there is a main power station. From there, power is sent to different sub-area power stations. From there, it is supplied to different houses. And you might have seen this sub-area power stations in your locality. At the main power station, there is a step-up transformer. And from the step-up transformer, you will get high voltage, but at the same time, you will get low current. So the high voltage and the low current coming from the step-up transformer at the main power station is given to the sub-area power stations. Okay. When the current is reduced, the heating effect will be reduced to a great extent, right? And the power loss is also minimized to a great extent till it reaches the area substations. At the area substation, the step-down transformer is used. This transformer will reduce the voltage and then increase the current, which is then supplied to the houses. So the power loss will not be very much, as the distance between the houses and the area power substation won't be very large. Okay, so transformers are used to regulate the voltage. Many appliances use voltage stabilizers. Example, TV, fridge, all uses voltage stabilizers which regulate the voltage so that the electronic devices are not harmed when there is fluctuation in the voltage. Okay, so these are some of the applications of transformers. The most important application is the transmission of power over long distances, and another application is that of it is used in voltage stabilizers. How is it possible in the case of long distance power transmission? See, there is a main power substation, and from that substation power is supplied to the small area substations nearby your locality. So from here at this main substation, step up transformer is used, and from the step up transformer you will get high voltage but at the same time low current. Okay, and this current is supplied to the sub area power stations, and the distance between this main power station and sub area power station is very large. So if high current flows through such a long distance, more power loss will be suffered. To avoid that, the step-up transformer is used and the voltage is increased and current is decreased so that the power loss can be minimized till it reaches this substations. From the substations, current or the power is delivered to our house, and the distance between the sub areas and our house or all the houses in that locality will be less, so not much power loss is experienced. And at the substation, step down transformer is used so that it decreases the voltage, at the same time increases the current. So high current is provided, and that high current comes to our home. Okay, since the distance between the sub stations and our home is less, not much power loss is suffered. So this is the main function of transformer in the long distance power transmission. Okay. Now, what are the important possibilities of energy loss in transformers, or what are the different areas of energy loss in transformers? So the first area is that of the flux leakage. We know that there are air gaps between the primary and secondary coil. Okay, just recall the structure of a transformer. So in between the primary and secondary coil, a space is there. That means air gap is there. So because of which the change of flux which is associated with the primary coil is not completely transferred to the secondary coil. So if the change of flux associated with the primary coil is 10, that change 10 is not completely transferred to secondary coil. Only 8 out of 10 is transferred to the secondary coil because of this air gap. Okay, and in order to reduce this loss, the secondary coil can be wound over the primary coil, and then the coil looks like a toroid. In the case of toroidal transformer cores, over the primary coil, secondary coil is wound, and as a result there is no air gap in between them. Okay, so toroidal transformers can reduce the flux leakage and thereby the energy loss due to that flux leakage. Okay, what is the structure of a toroidal transformer? So suppose this is the primary coil. Over this primary coil, secondary coil is also wound like that, like this. So there won't be any air gap between the primary and secondary coil, and there won't be much flux leakage. Okay, and the next area of energy loss is resistance of windings. Wire used for the windings has some resistance, and so energy is lost due to the heat produced in the wire, because if there is resistance, heat is produced as per as I square R. So energy is lost due to this heat produced, and if the area of cross section of the wire is increased, then the resistance will be reduced, because resistance is inversely proportional to area. So if thick wires are used in the windings of primary and secondary coil of the transformer, resistance will be less, and the amount of heat lost because of the wires can also be minimized. So resistance of windings is another area of energy loss, and it can be minimized by using thick wires. Okay, and the next source of energy loss is eddy currents. This soft iron core gets heated up because of the magnetic flux, and as a result eddy currents are developed in the soft iron core, because it is a conductor, and the currents induced in a conductor due to the change in magnetic flux is eddy currents. So eddy currents are developed, and due to eddy currents heat energy is generated. The core gets heated up because of the eddy currents, and this will harm the transformer core. In order to prevent this, laminated core can be used, and we had discussed about the lamination in the electromagnetic induction chapter. Whenever laminated core is used, what happens? An insulation is insulated. Whenever laminated cores are used, it is insulated, and because of that insulated covering, eddy currents are not able to produce the heating effects. Okay, the core is protected from that heating effects. So these are some of the energy losses in a transformer. So with this I am concluding my session, and also I am concluding this chapter, alternating current. Notes of the topic and YouTube video have been uploaded. Just go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe, keep learning. Thank you.